Hello guys, welcome back to my channel. Today we are going to understand how Langchain works. Since 2023, AI has been implemented everywhere and all of these systems are relying heavily on the Langchain framework. So it's very important to understand how it works. Now there are so many other frameworks like PyTorch, Django, TensorFlow, but they are very vast and need a lot of time to learn. But Langchain has been created very recently and it has been a very short amount of time, so that's the reason why it has very less number of methods that we have to learn as of now. So I'll explain how we can use Langchain for basic LLM conversations. Then I'll explain what is prompt template and how we can use prompt engineering. Then we will look at uh, and then we will look at a chain of LLM usage. Okay, so once all of this is done, we'll have a very good understanding of how Langchain works, and then we are finally going to implement a RAG out of Langchain in a matter of seconds. So let's get started. LLMs are very easy to work with, by the way. So all you need is a model and a tokenizer. So we can't use any tokenizer that we want. We have to use the tokenizer that was used to train the LLM. Okay, so while the LLM was being trained, if XYZ tokenizer was used, we have to use the exact same XYZ tokenizer every time we want to use the larger LLM. So let's take Llama model along with the tokenizer used while training the model and ask questions to the model. So to do this, we must first take the user input, convert that into tokens, pass it to an LLM. Once we get the predictions from the model, we can print it. So to do all of this part, we can create an automatic pipeline with the help of Hugging Face. So here you can see that I'm implementing the model along with the tokenizer, and also I'll create a few parameters for the model prediction. Now let's pass all these things to a pipeline. All that is left to do now is to pass a user input question. So here you can see, once we do that, we can see that we will be able to get the output from the LLM directly, and the amount of time it takes for the prediction depends upon the power of your computer. Okay, now let's understand what is prompt engineering. For that, I'm going to use a different file with a few changes. Now if I change up the previous file by adding something called as a template, where I'll write down clear-cut instructions for what the LLM has to do. Okay, this is called as prompt engineering. So I'll simply take the same code and add template. This template will have few instructions and it takes one input. Whatever I pass as the input will be added to the template, and the combined string is what I will be passing to my LLM. The rest of the code remains the same with no changes whatsoever. Here I'm creating a template and telling it to take one input variable called as text. Now I'll take the same text that I've used in the previous example and pass it to this template now. The whole template along with the user input will be passed to my LLM. We can get the predictions just like before, but since we are using prompt engineering, they are bound to all the instructions that you have given in the template. Now if I modify this a little bit by removing individual elements and pass both of them to something called LLM chain, then I can simply say chain.run and pass any text as input. So this way I can reuse the chain as many times as I want and create new ones easily with the help of the exact same template. So not only that, but also we can create a link of chains where the output of one chain goes into the input of second chain. Here I've created two chains. Now I'll pass something called sequential chain. So this will automatically print the output of each chain and also pass the output as input to the next chain. So this was about chains. Now let's understand how to build chatbot. So far we have been using prompt template, this is just a template for user inputs. But Langchain gives us few types of templates, such as system message, human message, AI message, similar to sequential method that we used earlier, where one output becomes input for another chain. Here we are going to use an order as human message, AI message, human message, AI message, and this goes on forever. So we can use this block of code to simply start the conversation. I hope the things have been clear so far, because now we are going to learn something a bit different. It's called as RAG. RAG stands for Retrieval Augmented Generation. So ChatGPT can answer many things, but it can't answer something related to your specific company. Imagine if you want to know who is the manager of a certain department or what is the strength of a certain team in your company, LLM can't do that. So let's go ahead and understand how RAG actually works like. So here I've got a small simple architecture diagram to explain you that same thing. Now let's imagine you have a bunch of documents. Now with the help of LLM, we are going to convert these documents into embeddings. So once I convert them into embeddings, we can store them in a vector database. So this is the most important and the most primary step of creating a RAG system. So let's try to understand this in depth on how we can convert these documents into embeddings. If I go up here, okay, so we got these documents. Now for each one of these documents, I'm going to read all of the content inside of the document in the form of a string. Now all these strings will be broken down into smaller pieces. These pieces are called as chunks. For each chunk, we are going to do some cleaning up part. So that will include removing of stop words, removing of unnecessary words and all. Then we are going to do stemming and lemmatization. So once I do lemmatization, I'll have each of those words broken down into its base form and also separated, and it will be converted from one chunk into an array. Now each of these words, including the starting token and the ending token, they have to be converted into numbers. So this is where tokenization comes in. So as I said in the beginning, tokenization is a very important aspect whenever it comes to LLM models. This is the reason why. So once I have the lemmatized corpus, I'll convert them into tokens. Now these tokens will be converted into embeddings, which are of higher dimensions. Okay, so here I've put just 3 dimensions, but basically embedding models will create embeddings of around 8 or 9 dimensions sometimes. Okay, and also the number of elements inside of each vector is way more than 3 here. This is only for example's sake. Okay, now once I have this embedding, the advantage that I get from an embedding over tokens is that this captures semantic meaning. So if I go to the diagram below, here you can see from all the documents that I've got, if I color code similar ones together, I can see here that these 3 documents are very closer to each other, which means their embeddings, when I plot them on a 3-dimensional plane, these 3 are very close to each other, and these 3 are very similar, so they are very close to each other. But both of these, like this set and this set, are completely different set of documents. So that is the reason why you can see that they are very far away from each other. So once you create an embedding, it captures the meaning of that sentence, meaning of the context that is present in the document. So in that way, similar embeddings will be grouped together. That is the advantage that you get with embeddings. Now if I take all of these embeddings from each of these documents, I'll store all of them in a vector database. So this vector database is one of the most important component of the RAG system. Now once I have this vector database ready, whenever a user asks any question, this question with the help of LLM will be converted into a vector embedding again. So all of the same process that we have followed here, this exact same process will repeat for the question. So this embedding will be used in the vector search. So because I have a vector database, I can simply use this vector and try to find all the similar embeddings, all the similar vectors. So that basically means I'm going to find all of the similar context. So if I ask a question related to some particular topic, and if any one of these documents has anything related to that particular topic, that context will be extracted and it will be presented to us here. When I have this context, I can pass the context along with the question to my LLM. So I can write a prompt template saying that you will have to answer this question only on the basis of this context. Now I'm giving it the question along with the context which has the answer as well. So since both of these are going to be passed to the LLM, it becomes very easy for the language model to give us the final answer. The same final answer will be presented to the user. So that is how a RAG system works on the backend side. So let's go ahead and implement this in Langchain. So to do that, the first thing that we have to do is this part, wherein we are going to take the documents and create a vector database out of it. So here you can see that I'm loading all of my documents as strings, which will be converted into chunks, and these chunks will be passed to the vector store. Okay, let's store this in a variable called as db. Now I will use something called as retrieval QA, which is a type of chain that is specifically designed for RAG. I'll pass my LLM, my DB and my template as well. Now let's pass user input, and this will automatically be added to the template, and a similar context will be extracted from the database, and a final output will be generated by the LLM. I hope this video was helpful in making you understand what is Langchain and how we can use it. And also all of this code will be uploaded onto GitHub. The link will be in the description. So if you like this video, please like and share it, and also please don't forget to subscribe to the channel. Thank you for watching.